नमस्कार दोस्तों, मैं अजीत बहादुर आप सबका सोलोइज में पैशन पे स्वागत करता हूं और आशा करता हूं कि आप लोग स्वस्थ होंगे। दोस्तों, हर हफ्ते की तरह हम इस बार भी कुछ नया लेके आए हैं, दैट इज़ BESS, दैट इज़ बैटरी एनर्जी स्टोरेज सिस्टम। और मुझे यकीन है कि भाई आप लोग भी इसे जानना चाहते होंगे। क्या है कि भाई हर जगह या आगे आने वाले दिनों में स्टोरेज की बात हो रही है। इनफैक्ट हम सब सोलर इंडस्ट्री में काम कर रहे हैं और अब बात आती है कुछ स्टेबिलिटी की, कुछ ग्रिड स्टेबिलिटी की, कुछ TOD की बातें हो रही हैं। फिर उसके बाद अलग अलग टेक्नोलॉजीज़ आ रही हैं। हम अपना खुद का स्टोरेज करके हम अपनी रिक्वायरमेंट फुलफ़िल कर सकते हैं कि नहीं, करेंगे तो कितना का स्टोरेज लगेगा और उसके लिए कैसे साइजिंग डिज़ाइनिंग होगी। ये तमाम चीज़ें हमारे मन में ज़रूर आती होंगी। इनफैक्ट आप लोगों की जानकारी के लिए बता दूं कि भाई ये सारी चीज़ें हम अपने ट्रेनिंग सेशंस में भी कवर करते हैं। और जैसा कि आप हमारे स्क्रीन पे देख सकते हैं, वी हैव डिज़ाइंड स्पेशली शॉर्ट टर्म ट्रेनिंग्स। क्या है कि भाई आप में से कई लोग इंडस्ट्री में ऑलरेडी काम कर रहे हैं। अब आप में से कई लोग चाहते हैं कि भाई हम अपने स्टाफ को सिर्फ इतना सिखाना चाहते हैं कि भाई सिस्टम या साइट सिलेक्शन कैसे किया जाता है, सिस्टम की साइजिंग डिज़ाइनिंग, कंपोनेंट्स या कॉस्ट पेबैक, ये या फिर कह दो कि भाई डिस्कॉम का पोर्टल कैसे हैंडल करना होता है, नेशनल पोर्टल कैसे हैंडल करना होता है, या फिर कह दे कि भाई आपका DCR पोर्टल कैसे हैंडल करना होता है। आपके पास या आपका स्टाफ अगर ये जानता होगा तो आपका आधा से ज़्यादा सरदर्दी निकल जाएगी। एम आई राइट है? मैं चाहूँगा कि भाई हमारे जितने भी दोस्त लोग हमारे साथ जुड़े हुए हैं वो ज़रा बताएं कि भाई क्या आप हमसे सहमत हैं या नहीं। इसी बहाने हमें ये भी पता चल जाएगा कि भाई आपको हमारी आवाज़ आ रही है या नहीं। ऑडियो वीडियो क्लियर की जगह पे मैं पूछना चाहूँगा कि भाई क्या आप चाहते हैं कि भाई आपका स्टाफ ये जान ले कि भाई नेशनल पोर्टल में कैसे काम किया जाता है, स्टेट पोर्टल में कैसे, डिस्कॉम के पोर्टल में कैसे काम किया जाता है और DCR को कैसे हैंडल किया जाता है। क्या आपको ये चीज़ काम आएगी या नहीं? और इसी को ध्यान में रख के हम लोगों ने ये शॉर्ट टर्म ट्रेनिंग्स भी हमने डिज़ाइन किए हैं, जहाँ पे हम 5-5 दिन 6-6 दिन के अंदर हम ये कवर करने वाले हैं कि भाई क्या होता है, कैसे होता है। और आपका स्टाफ अगर उसे सीख लेता है तो आपका आधा से ज़्यादा काम हो जाएगा। इनफैक्ट नेशनल पोर्टल, स्टेट पोर्टल, DCR ये भी हम उसमें कवर करने वाले हैं। हाँ, हेमराज कुमार जी, गुड मॉर्निंग। हाँ सर, आई हैव सम क्वेश्चंस रिगार्डिंग BESS। नो डाउट सर, हम आज के जो हमारे जो एक्सपर्ट हैं शिवा कुमार सर, शिवा सर, ही इज़ विद अस और वो आपके सारे क्वेश्चंस और सारे डाउट्स को क्लियर करेंगे। मैं अपने जितने भी दर्शक हैं, नरेंद्र यादव जी, प्रशांत सबत साहब, सिद्धार्थ जी, हीरालाल गुज्जर साहब, मोहम्मद सईद साहब, रविशंकर सिंह एंड जितने भी हमारे दोस्त हैं उन सब का आज के लाइव इंटरेक्टिव सेशन में स्वागत करता हूं। और चलिए अब हम बढ़ते हैं। आज के जो हमारे एक्सपर्ट हैं उनका हम पहले इंट्रोडक्शन करा देते हैं, फिर वो हमें आगे का बताएंगे। तो शिवा सर, वंस अगेन वेलकम है। बिकॉज और दोस्तों आपको जानकारी के लिए बता दूँ कि ही इज़ जॉइनिंग विथ अस फ्रॉम ऑस्ट्रेलिया एंड वी आर रियली थैंकफुल फॉर हिम दैट ही हैज़ टेकन टाइम फॉर अस एंड आवर टीम members so to share his knowledge, and he is having almost 15+ years of experience। अगर हम गीगावाट्स की बात करें तो ऑलमोस्ट 6 गीगावाट्स, he is having experience of 6 gigawatts and he has done many projects from kilowatt to megawatt, megawatt to gigawatt and presently he is handling storage. Mati, he is doing projects on storage also. Welcome to Solo is my passion, sir.
Thank you, sir. Thank you. It's always a pleasure joining you and meeting a team of enthusiasts who always want to know more and who are interested in the solar business. And I think these training sessions are very important because the better you train yourself, the better product you give to the customer makes this business sustainable. One wrong product or one wrong installation can easily become a word of mouth and kill business. It has always happened in every business, but I think training is very important in solar. And you for doing such a great activity. Many thanks from all of us, sir.
Thank you, sir.
So
Thank you.
let's
It's all support is from your side, sir, and many more experts are connected with us. In fact, few
yeah.
policy makers are also with us, and we are thankful to all of you. And दोस्तों यहाँ पे एक चीज़ आपको और क्लियर कर दूंगा कि शिवा सर आपको ये सारी चीज़ें जो है वो इंग्लिश में बताएंगे। क्या है कि भाई इंग्लिश में ही वो बता पाएंगे। अ, अमित जायसवाल जी, गुड मॉर्निंग। डिग्निटरीज सर आर, मेरा क्वेश्चन लास्ट टॉपिक को लेकर है। शिवा सर, वेरी सिंक डिवाइस। very good. Amit Jaiswal, sir, Shiva sir, there is one question from the last session because he had attended the last session, also the DGPV
Okay.
sync है।
Yeah, yeah, sure,
सो
sure.
वो सिंक वाले डिवाइस का नेम क्या है अच्छे कंपनी का? ही वांट्स टू he has the DGPV sync equipment which you were
Yeah, yeah,
telling now.
yeah.
You just tell
The PLC,
the name of
okay,
the
see,
manufacturer.
basically, I don't, I'm not representing any manufacturer, but I can tell you one good name. It's called DIF, DEIF, DIF. This company is manufacturing PLCs, programmable logic controllers, which can synchronize DG set with DG set, and they kind of started manufacturing a programmable logic controller PLC for synchronizing solar with DG sets. So DIF is one company which you can approach, and they are from Denmark, and the quality of the product is very good. If you are thinking about making a PVDG sync for a bigger project, I think DIF will also work out reasonably well for you.
Sir, give at least two to three options because DAF, is it available in India?
Oh, yeah, it's available in India. Yes, DIF is very much available in India.
Uh,
Nowadays, there are also some local manufacturers, Indian manufacturers, who have come up with PV Sync circuits and stuff. But I don't know the quality of the product, so I don't want to mention any names here
okay,
at the
no
moment.
issues. And
DIF is a company which
from
is
where you
well
can get
reputed.
it, sir?
You can just Google DIF and see where they are located. I think mostly in Bangalore or Mumbai, you can very well connect with the team and they can arrange it for you.
Sir, since you were from you had already worked in Chennai, and
Yeah.
you have already used these products, huh?
Yes,
So
yes.
from where did you procure this in India?
Mostly we were procuring it, I would say, from Mumbai, Pune. Yeah,
Okay,
it was from Pune. Yeah.
yes. हाँ, तो
But you guys who want to do this can also reach out to me, and I can, based on your requirements, I can suggest the right person for you.
ओके, नो इशू सर,
Yeah.
थैंक यू है। तो एंथोनी सर भी आ चुके हैं। एंथोनी सर नमस्कार, सोमनाथ जामदार जी नमस्कार, नीरज गौतम साहब नमस्कार, जय हिंद है। तो चलिए, जहाँ तक मुझे पता चल रहा है कि भाई आवाज़ आपको आ रही है, एंड लेट्स मूव विद आवर टॉपिक दैट इज़ BESS। उससे पहले मैं जानना चाहूँगा कि कोई हमें ये बता दे कि भाई BESS का फुल फॉर्म क्या है। क्या है कि भाई आधे हमारे दोस्त लोग, कुछ लोग नए हैं, तो कैन यू जस्ट टेल मी व्हाट इज़ द फुल फॉर्म ऑफ BESS? BESS।
Okay, that's the first question that has come in, I think.
हाँ,
Okay.
यस,
I think we'll start with the presentation, which will step by step answer this for
हाँ,
them, sir.
यस यस
Yeah.
यस सर, डेफिनेटली। इट्स बैटरी एनर्जी स्टोरेज सिस्टम। हेमराज जी एकदम बहुत सही, सोमनाथ जामदार जी एकदम सही आपने बोला कि भाई BESS मतलब बैटरी एनर्जी स्टोरेज सिस्टम। सो सर, मतलब कि द बेसिक थिंग दे ऑल आर अवेयर अबाउट, नाउ जस्ट दे वांट टू नो। ओवर टू यू है, लेट्स मूव विद द प्रेजेंटेशन।
Sure, 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 sure.
दोस्तों आप सबसे रिक्वेस्ट है कि भाई आप पहले समझ लीजिए और एक पेन और एक कॉपी रख लीजिए। पेन और कॉपी तो हम कहाँ इस्तेमाल आएगा। हाँ, एक पेन और कॉपी रख लीजिए सो दैट आपके मन में जो क्वेश्चन है वो साइड में लिख लीजिएगा। और जैसे ही बीच बीच में शिवा सर क्वेश्चंस का डिमांड करेंगे, तो तब आप उस क्वेश्चंस को पुटअप कीजिएगा, हम उन क्वेश्चंस को एक एक करके ले लेंगे। ओ टू यू सर।
Thank you, sir. And welcome back again. let's start with our topic BESS, which is more going to be connected to renewable energy in this particular topic because we'll be talking more towards renewable energy getting connected to battery storage. Okay. And to start this topic, I would definitely tell you what you have to be prepared for. I mean, what you can expect out of this topic. This topic is going to be a topic which will talk about the evolution of the battery technology, which we all know, and where it has evolved now, and what we are expecting in the future. That's mainly what we are going to focus. And it will be a technical and also a non-technical, as I always do, so that even a layman person or a newcomer to the industry can understand it well. And thirdly, you can also think about the job opportunities which it is going to bring in. So not only listen to this topic as a technical seminar, but also think of the job opportunities which it is going to bring in the renewable sector. So all this put in is going to be our topic for today. Um, Renewable energy and battery storage solutions. So initially, we started installing solar in India, let's say about 10, 15 years back. Solar installation started booming in India slowly, step by step. It was initially, let me just move on to the next slide here. Initially, the solar installations on houses or the batteries came along with solar mainly as a solution for power cut. In 2017 or even before that, in 2011 once, there was a power crisis in my state of India, which is Tamil Nadu. There was a power crisis. So in summer, we always had power cuts, a lot of power cuts. And you can imagine summer in south of India, it's going to be horrible without power. So people were looking at solutions or things which can support them during these power cuts. That's when the UPS market started booming. Batteries came into picture, and along with it came the solar also to support this. So that's how batteries came into the residential market, which is the start of the battery solutions, I can say. And then on, it moved on to the isolated cabins. Here it's very interesting because, like they say, did the egg come first or the chicken came first? It is actually the cabins which came first before the residential market. Solar and battery storage solutions were actually installed on such cabins first before it came into the residential market. That's the truth. And these cabins, as you can see, these cabins are mostly in remote places where there is no grid. And they can be for a military purpose, they can be for a forest educational purpose, or big towers which need power, but then they are remotely located. So they were not supported by the grid. And then came the solar solution along with battery energy storage, which was powering up the cabin for the person who was staying there, the equipments which was used there. This then also moved into microgrid solutions. If you were aware of this, many villages in Myanmar and the villages in Vietnam, and also for that matter, many villages in Africa were powered by microgrid solutions. When I say microgrid, apart from the two topics which we discussed earlier, where there was power cut, so we installed UPS batteries and solar to take care of our power cut times. Then the solution where we were installing solar and battery for the remotely installed equipments or cabins. But this microgrid solution is something I would say advanced than this because it can power an entire village. And here we are not only talking about battery solar, but it can also be a windmill which is connected to the batteries. And it can also be a small hydropower station which is connected to the batteries. And a small village like this was getting powered by the battery. during the non-operational hours of the renewable energy. So this was a microgrid solution which was also installed. Now, moving to the next big topic, which starts here. We install renewable energies across our requirements, let's say in houses, in industries where we have to reduce the power bill, in villages where there is no grid. But the biggest negativity of the renewable energy installation is it is unpredictable. You cannot predict nature. So it's very unpredictable, where you install a solar plant of 1 megawatt and expect this 1 megawatt power to be coming out of the solar panel always, because it can easily be reduced by a small cloud moving over it. It is unpredictable, unreliable, and also sometimes not available. So here is where our battery plays the vital role. The battery becomes the future. Have you heard of this term? I mean, in near past, battery is the future. Battery becomes the future is always been told by many people. Battery becomes the future is always heard by us. So here is our topic, which is now more going to be focusing on why battery becomes the future.
एक मिनट सर सर लेट्स आस्क द ऑडियंस ऑल्सो, आपको क्या लगता है कि बैटरी फ्यूचर होने वाला है? इज़ इट द फ्यूचर? ज़रा फटाफट हमें बताइए सर। नरेंद्र यादव जी, हफीज़ जी, नेचर की किताब, वेलकम नेचर की किताब है, मोहम्मद सईद साहब, सुलभ शाह साहब, सोमनाथ जामदार जी, हेमराज कुमार जी, ए बी एनर्जी सॉल्यूशंस, अमित जायसवाल साहब, आपको क्या लगता है कि ये जो बैटरी की हम जो बात कर रहे हैं, या जो BESS की जो बात कर रहे हैं, या स्टोरेज की जो बात कर रहे हैं, क्या ये हमारे आगे आने वाले में फ्यूचर में काम आने वाला है? यस सर। शिवा सर, everyone is saying Hafiz ji said yes, Somnath Jamdar sir said yes, it will. Hiralal Gujjar sahab also said yes, Sulabh Shah sir also said yes, Mohammad Saeed sahab also said yes. So everyone is clear that this is the future.
Yeah.
Hamraj said yes sir, it will get more reachable to public after knowledge getting by everyone. Thank you sir. Business machine suppliers yes, Praveen Achankar sir yes, Ravi Sangvi sahab yes sir. Over to you sir.
Okay. Batteries being the future, I may be talking about something which you have never even heard of, or never even imagined of, which is already happening in the industry right now. Countries like Denmark, Germany, and all these, even Australia is doing this as of now. Before we get into the topic, I'll explain one small incident which happened in Germany a few years back, which was close to 2010. Germany at that point of time was almost running in renewables, because they had so much of, they were shutting down all their non-renewable sources of power, and they were running only on renewables, and most of it was solar. And a solar eclipse was expected at one day. Now imagine a country running most of its power requirements through solar is now going to face one day that is just for few hours of not a power cut, but the energy that is going to come out of solar is going to go down at an instant, because when solar eclipse comes in, a bright shining sun will instantly just turn off for 2 hours, and then it comes on. So for this 2 hours, the country has to pump in more power, because there is going to be more demand. The demand is not going to reduce in the country, so the power has to be pumped instantly from a power station. Let's say a thermal power station has to pump in more power to the country to compensate on what was lost because of this solar eclipse. So what they did, 1 week before the solar eclipse, they started announcing on every radio. If you go on a car, the car radio is always telling you to turn off the solar plant on that particular day. Just on that particular day, they wanted all the solar plants in the country to be turned off because they didn't want a fluctuation in the grid. If you are going to run on that particular day, the whole country with the support of solar and also the grid, the instant change in demand and generation is going to be an imbalance in the grid. So they were announcing very rigorously, telling shut down the solar plants in the country. And this was also done in those countries remotely by uh, SMA inverters, for example, can also be remotely turned off. For that matter, forget about Germany, come to India, our own country. There is a district in Tamil Nadu which is called Tirunelveli. It is mainly supported by wind power. There is wind for 9 months in this particular district of Tamil Nadu. If you install a windmill in any part of India, I know many parts of India is getting installed by windmills, but this particular part of India, if you install a windmill, the windmill can spin for a minimum of 9 months. A minimum of 9 months, you can expect a good wind in this area. So that particular area was having surplus of energy. The area had surplus of energy, and at some points, when there is surplus and if there is no demand, the windmills were turned off by the government. So the government had, let's say again, a small device sitting in the windmill station. I don't exactly remember the technical name for it, but it's just a relay, you can say. It is being controlled by the government electrical operators. They just simply turn off the windmills when the demand is more, or when the wind is more, and if they don't want to damage the windmills, they simply just turn off the windmills. And these things were happening few years back, and now the future is changing to something else, which is what we are going to discuss. This name on the screen, you just have to Google this, and there are good case studies, and there are nice videos also on YouTube which talks about this installation in the south of Australia in a town called Hornsdale. And it has a 150 megawatt of wind farm. It's not a solar farm, it's a wind farm. And Tesla shook hands with this project. Why? Because in 2017, Australia had an energy crisis. So Australia, you can imagine, such a big country, and generating power in it's a country, and it is also a continent. So it's so big. Like generating power from one corner of Australia, you cannot just push it to all sides of Australia. So there can be voltage losses, there can be transmission losses, many things are happening. But in this particular stage where there was an energy crisis, there was a 150 megawatt of wind farm which was supported by batteries. So what happens is when there is surplus energy generated by the wind farm, it goes into the battery, sits there, stays there, and gets released when there is a demand in the grid or in the country. So it just generates, pushes in, also at the same time treats all the loads, but the excess is pushed into the battery. It's not wasted. It's not like how I told the story of Tirunelveli where the wind farms were turned off. It is still happening in India. In India, still the wind farms and also the solar farms in future will have the same effect. If there is surplus power being pushed into the grid, the solar farms, I know the policy as of now is not allowing the solar farms to be turned off by the government, but the wind farms can always be turned off by the government when there is surplus power. But soon it will also be transferred into solar farms because India as a country is now moving towards 50 percentage of its usage from renewable energy. So imagine at this stage, an installation like this is soon gonna happen in India. So read about Hornsdale while we discuss on what is happening there. Now, battery technologies. Battery technologies involved in BESS. What is the technology involved? Let's imagine a factory let's start from a factory. Let's start from an industrial or a commercial installation. There are two technologies. One is peak shaving and load sharing. Peak shaving and load sharing. You can also note it down because you can again go through deep. And in our training sessions, we'll be talking more on peak shaving and load sharing techniques, which hand in hand go well with each other. It's very simple. In simple terms, in India, let's say there is a peak hour consumption and there is a maximum demand charge. So if you take an industry which is connected to 1 megawatt of power, so the allotted power to the industry by the discom is 1 megawatt, and they have a maximum demand charge. So in 1 megawatt, if they reach only up to 500 kilowatt, then the maximum demand charges are less. But after that, every 1 kilowatt they increase in their demand, there is a charge for them. This is one thing to understand. Secondly, there is also peak hour charges. So in again in India, in our country, we have peak hour charges. If you have an industry which runs two shifts, morning and also in the evening, the power consumption during the daytime, that is midday, the power consumption or the power prices are very low. But the same power consumption, if it happens during the night when the demand is more for power, then the charges are high. In the non-peak hours, the prices can be close to 6 rupees. And in the peak hours, that is in the early morning and in the night times, the charges can be up to 7 to 8 rupees. So it can even go up to 2 rupees. So these numbers are not exact, right? This is just a value which I'm just giving you as a number so that you can balance the numbers in your mind. So it can go up to 2 rupees more on the peak hours. This is happening in our own country. There is a peak hour generation charge, and there is also a um, peak demand charge. So you can only expect so much power to be pulled from the grid. And beyond that, if you go, then you have a peak demand charge.
Sir,
Until now, if there's anything, you can please. Yes, sir. Over
sir,
to
this
you.
is this is this is already it's going to be implemented in domestic sector also, but in commercial
Sure.
sector it's already implemented. There is a
Yeah.
concept called TOD, time of day. In that
Yeah.
time of day, they have already cleared that if you consume in this time zone, the charges will be
Yeah.
like this, and if you
Yeah.
consume in the evening time, the charges is 1 rupees 20 paisa more than the regular charges.
Depending on which part of the country you are,
नहीं
like
नहीं in
in.
right now it's already implemented in for CNI segments above 25
Okay.
kilowatt in Maharashtra,
Perfect.
and
Yeah.
the government has already released the circular that from 2025 onwards the same thing will be TOD will be applicable for all discoms and for domestic sector also.
Okay. Got your point,
फ्रेंड्स,
sir.
आप लोगों ने इस सर्कुलर के बारे में जानते हैं ऐसा कुछ सर्कुलर आप लोगों ने पढ़ा है कि टीओडी आने वाला है? सोमनाथ जामदार जी, दिलराज जी, नीरज गुप्ता साहब, हाँ, जितने भी दोस्त हमारे साथ अभी जुड़े हुए हैं, हैव यू एवर हर्ड या किसी ने ये देखा है या पढ़ा है कि भाई टीओडी आने वाला है या लागू होने वाला है? हाँ ना, हाँ ना, है, यस नो, यस नो, लेट्स चेक आउट। क्या है कि भाई डिमांड, देखिए, जब तक हमें ये नहीं पता लगेगा कि भाई क्या आने वाला है तब तक हम उसके बारे में तैयारी कैसे करेंगे? फिलहाल आप लोगों ने ये तो कंफर्म कर दिया कि भाई व्हाट इज़ BESS, और वो चीज़ आने वाला है। रियाज अहमद साहब, यस आई हैव हर्ड। आनंद राज सर, यस उन्होंने भी गया। प्रेम बजाज सर, यस अर्लियर दिस ईयर, यस हाँ बोला था। यस आई हैव, बट द रेसिडेंशियल सेक्टर इज़ बिट डिफिकल्ट टू इम्प्लीमेंट। सोमनाथ जामदार सर, नो इश्यूज़, बट धीरे धीरे ही सब चीज़ का होता है, एंड वो आएगा धीरे धीरे। तो अभी CNI सेगमेंट्स में तो आ ही गया है, अब बाकी सब सेगमेंट्स में भी धीरे धीरे इम्प्लीमेंट करेंगे। हाँ, जैसा आपने बोला कि भाई डोमेस्टिक में और एग्रीकल्चर सेक्टर में ये थोड़ा सा लेट आएगा, लेकिन बाकी सब जगह तो आ ही जाएगा। आपको बिज़नेस तो है ही सर, धीरे धीरे बिज़नेस करेंगे तो क्या है कि भाई इतना बड़ा सेगमेंट है, हमें बिजनेस भी तो चाहिए, हमें अगले 5 साल 6 साल में मतलब कि ये दिख रहा है कि भाई देर इज़ ए ह्यूज बिजनेस अपकमिंग, वी इम्प्लीमेंटेड मिनी ग्रिड। ओके, वेरी गुड सर, आनंद राज साहब। चलिए ओवर टू यू सर। यस, दे हैव हर्ड।
Um, Yeah, so it's good to know that this awareness is already there and the government is already implementing such things, because the evening times is the demand time. So evening times and the early morning times, normally the price of power is more in our country. Okay, let's connect that to battery now. Now, imagine a factory, like I said, is connected to a 1 megawatt of load. It is the sanction load to the factory is 1 megawatt, and they will be paying for their maximum demand also. So there is a maximum demand charge. So up to maybe a 200 kilowatt will be given to them for free. But after that, every kilowatt usage they do, let's say they are going to use up to 600 kilowatt. So the 200 kilowatt you use, there is no any additional charge. But above that is going to be an additional charge because you are taking 400 kilowatt more. That's called a maximum demand charge. Now here is where you can use batteries. You can use batteries. Now we are not talking about solar. We can also install solar and push power into the load so that the load at this point of time is only consuming 200 kilowatt from the grid and remaining is given from solar, let's say. But as we discussed earlier, solar is very unpredictable, it is unreliable, and it can only be a secondary source of power. It can sometimes be unavailable also. So we need batteries which are connected along with solar, and we know that batteries are steady source of power. So if you imagine this factory is consuming 600 kilowatt at this point of time, you can schedule the battery to be giving 400 kilowatt continuously to the load. This can be done, and this is called peak shaving. Or you can do one more thing. Imagine the daytime consumption of electricity from the grid is cheaper and the nighttime is more. So you can always charge your batteries. The battery also becomes a load inside the factory, but it can be charged from the power from a solar or even from grid for that matter. It can be charged and it can be released during the peak hour. So this is the load shifting technique which we can do using batteries, which can actually save a lot of power. I have worked with some steel suppliers, the people who make the TMT rods and all those things, and they are heavy consumers of electricity. And imagine installing one battery and saving so much of, even if it is 2 rupees or 1 rupee extra per unit, in one day they can save so much just by adding one battery. And the return on income and return on investment can also be very favorable when it comes to such high consumers. This is something. So two things to remember. One is peak shaving, and the second is load shifting, load transfer, whatever you call it.
So
You can,
it's peak shaving, SHAVING or
yeah,
SAVING?
peak shaving. It's
S
you
H
are
A V
shaving off
I.
the peak. Yeah,
Okay, peak
shave,
shaving. Huh? This is the
peak
concept.
shaving.
And
Yeah,
second
yeah, yeah.
is
Load shifting,
load shifting. Okay, these two
just shifting
concepts.
the load. Yeah, yeah,
तो
yeah.
फ्रेंड्स ये दो कॉन्सेप्ट लिख लीजिए, ये दोनों चीज़ अपने काम की चीज़ है। ओ टी यू सर।
The third concept in which the batteries will play a vital role is frequency response. Frequency response. Okay. What you see on screen is demand versus the generation. So on the left-hand side is the demand, the factories, the houses, the consumers like us who consume electricity. And on the right side is suppliers of electricity. It can be a coal plant, a thermal plant, it can be a renewable source of energy. So when at one point of time the demand increases, when demand increases and the supply is low, then the frequency of the grid will go on the lower side. The frequency of the grid always has to be maintained at 50 hertz in India, and in some countries it's 60 hertz even. But the frequency of the grid has to be maintained at 50 hertz, and this depends on exactly on this concept. The demand of the grid goes high, but the generation is not so much. Then the frequency goes lower. On the other hand, if the generation is higher and the demand is low, if the generation is high and the demand is low, then the grid will go, the frequency of the grid goes on the higher side, which is crossing 50. There was one point when it was COVID, and we were all told to turn off all the electrical appliances in the house and burn just one light or one candle to honor all those heroes who worked for the COVID. You remember that, right? So imagine at that point of time, the grid would have had no demand at all because it was a request. It was a request coming from the central government, and most of us did that, I guess. So at that point of time, the demand in the grid would have gone very low and the generation would have been the same because the generation in all those power supplying plants would have been the same. So this would have created a high or low, you think? It's going to create a high frequency in the grid because there was more energy in the grid, but there was no demand at that particular time. So in such cases, batteries will be helpful. I'll tell you. Countries like Denmark and Germany, again coming back to the old story where we were talking about a solar eclipse, Denmark also has a lot of renewable energy sources. Denmark, Germany, and all these countries are countries which are more than 50 percentage relying on their renewable energy sources, which are unpredictable, unreliable, and sometimes also not available. So what they do is like how we install the open access solar projects. They install a big solar plant and um, connect it with a battery bank. And these battery banks are big, huge. So they install a solar plant on open ground and simply connect it with a big battery bank. These battery banks are huge. They are huge as in each container can be a 10 megawatt hour storage. So there will be about 50 megawatt hour storage just waiting there. And the government signs grid forming agreements with these companies. So the government signs grid forming agreement with these companies telling, yes, I will make use of your battery power whenever I need it. The best part of battery is when this happens, the thing that is shown on the screen happens, when there is a high demand on the grid, the battery can instantly kick in and push power into the grid. At the same time, this is the most interesting part. When there is more power in the grid and there is less demand, the battery can also act as a load. The battery can suck power from the grid and still stabilize the grid. So governments are signing these agreements with parties who have batteries installed in their solar plant to stabilize the country's grid, and which we are also moving towards. We are also moving towards such a situation in Tamil Nadu mainly. If you come to the south most part of Tamil Nadu, there is huge installations like also in our Rajasthan and all those parts. There are huge installations of solar, wind. There is also hydropower. Imagine if at one point of time we want to run the whole country with the support of renewable power, we definitely will have to implement these batteries into picture who can equalize the grid by pushing power and also pulling power. That's the beauty of battery, because the battery can push power when the grid needs it, and also take in power when there is more surplus energy available in the grid.
जी।
Yes. So the next, there are some techniques involved in these batteries, which I will only touch on the topics, but let's we'll not be going very deep because it's a very big topic, and there's no time to discuss it very deep.
शिवा
So
सर,
the main, yeah,
लेट्स टेक सम क्वेश्चंस आल्सो सर, हैं?
sure, sure, yes, yes, please.
फ्रेंड्स, आपके मन में अगर यहाँ तक के लिए कोई क्वेश्चन है तो आप पूछ लीजिए। इनफैक्ट मैं आप सबसे एक क्वेश्चन पुट अप करना चाहूँगा। जैसे हमें अभी शिवा सर ने बोला कि भाई, इनफैक्ट हम भी जानते हैं कि भाई अगर हम बैटरी की बात करते हैं तो हमें स्विच ओवर टाइम जो है वो कुछ फ्रैक्शन ऑफ सेकेंड्स रहता है। मतलब कि हमें जैसे ही कुछ चाहिए होता है तो हम वो उसमें विद इन फ्रैक्शन ऑफ सेकेंड्स हम उसमें डाल देते हैं। तो क्वेश्चन ये है कि भाई हमारे पास जो बाकी के रिन्यूएबल एनर्जी सोर्सेस हैं, या हमारे पास जो बाकी सोर्सेस हैं, एनर्जी सोर्सेस हैं, मिसाल के तौर पे थर्मल हो गया या जियो थर्मल हो गया या विंड हो गया या हो गया आपका बायोमास हो गया, बायोगैस हो गया, तो उसमें कितना टाइम लगता है। अगर हम बात करें विंड की या हम बात करें थर्मल एनर्जी की सीधा, तो उसमें कितना टाइम लगता है स्विच ऑन होने में। मतलब कि अगर हम स्टार्ट करेंगे तो कितनी देर में एक्सपेक्ट करेंगे कि भाई उससे बिजली जनरेट होना चालू हो जाएगी। लेट्स चेकआउट है। अगर हम थर्मल पावर स्टेशन को स्टार्ट करेंगे तो हमें कितने देर में वो बिजली आना चालू हो जाएगी। अभी हम बैटरी की अगर बात करते हैं तो विद इन फ्रैक्शन ऑफ सेकेंड्स और फ्रैक्शन ऑफ मिनट्स में हमें पास आ जाता है। तो if we say that if we start a thermal power station from starting point, तो within how many time है it will start generating electricity। आनंद राज जी, हेमराज कुमार जी, प्रेम बजाज, रियाज अहमद साहब, आनंद जी, सोमनाथ जामदार जी, इट्स 6 MIND या MONTH, 6 मंथ है या मिनट्स है? सोमनाथ है 6 to 5 to 6 मिनट है। ओके, और भी हमारे जो दोस्त लोग हैं ज़रा वो भी लिखें कि भाई अगर हम थर्मल पावर स्टेशन स्टार्ट करते हैं तो वो कितने देर में हमें ग्रिड को सपोर्ट कर सकती है। या आपके पास अगर कोई और दूसरी टेक्नोलॉजी है, जियो थर्मल हो गया, बायोमास हो गया, बायोगैस हो गया, या जो भी लगता है। हेमराज कुमार जी, द क्वेश्चन इज़ कि भाई जैसे अभी हमने देखा कि भाई सोलर में अगर हम बैटरी की बात करें तो बैटरी से हम अगर हम किसी को सपोर्ट करना चाहते हैं तो हम जस्ट ऑन करते हैं एंड विद इन फ्रैक्शन ऑफ सेकेंड्स और मिनट्स हमें उससे सपोर्ट मिल जाता है, हमारा ग्रिड को सपोर्ट मिल जाता है। और वही अगर हम बात करें दूसरे टेक्नोलॉजीज़ की, थर्मल या विंड या और भी किसी टेक्नोलॉजी की, तो वो कितने मिनट्स या कितने सेकेंड्स के अंदर ग्रिड को सपोर्ट कर सकता है। कुंचरिया जॉर्ज, विवेक शर्मा, मिनिमम 1 to 2 hours। ओके, रियाज अहमद साहब, रिक्वेस्ट यू टू put some light on safety aspects of BESS as there is a news of fire incidents related to batteries in EV। Okay, sure sir। Next is हेमराज कुमार जी का क्वेश्चन है, व्हाट इज़ कॉन्ट्रैक्ट लोड एंड पीक डिमांड एंड टीओडी। तो हेमराज कुमार जी, इसके लिए तो मैं आपको यही बोल सकता हूँ कि भाई इट्स ए बिग सब्जेक्ट। आपको थोड़ा सा ये बिलिंग पैटर्न को समझना होता है, कंज्यूमर के बिल को समझना होता है। तो वो चीज़ हम अपने ट्रेनिंग सेशन में लेते हैं और ये शॉर्ट टर्म ट्रेनिंग में आप ज्वाइन करके इस चीज़ टॉपिक को क्लियर कर सकते हैं। इस 7 to 8 डेज़ का सेशन रहेगा जहाँ पे शिवा सर भी और बाकी जो एक्सपर्ट्स हैं वो आपको ये चीज़ सिखाएंगे कि भाई व्हाट इज़ टीओडी, व्हाट इज़ बिल फॉर कमर्शियल फॉर ये। अशोक सोनी, सादर नमस्ते। मेगावाट का प्लांट के पर बीमा सिस्टम of thermal electricity, few hours. Okay, can you share some insight on the safety aspects of BESS? The oil and gas industry, nature की किताब, switch over time in thermal is very from hours to day. नेचर की किताब ने एकदम सही सर, नेचर की किताब हैज़ गिवन द परफेक्ट आंसर्स. द स्विच टाइम फॉर ए थर्मल पावर प्लांट कैन वेरी फ्रॉम आवर्स टू डेज. एम आई राइट सर? हेलो शिवा
Yeah.
सर.
Yes.
हाँ.
Yes, sir. Yes, yes, yes.
Now you said कि
So yeah,
बाबा
that
the switchover time for a BESS or from battery to grid is hardly few seconds or minutes. It can
few seconds,
a
few
few
seconds.
seconds. Huh?
Yes, yes.
And
Yeah.
for others, this thing, Riaz Ahmed also said कि coal-based solar plant can take several hours to start up from a completely cold state. Yes, this is true, sir. Over to you, sir.
Yeah. Okay. So that was good. That was a good question asked by you, sir. Yes. So that also becomes one big reason, right? Because when you are thinking of a future which in which the country itself is going to be relying on renewable energy, and such imbalances are prone to happen. So they will happen for sure, and you should be prepared for it. Is where batteries will come into picture, and that's one main reason why, in the middle of the topic, I said the topic is also about why batteries will be the future. Batteries will be the future and why. Okay, yes. So now let's discuss on the techniques the batteries have. The techniques the batteries will have to achieve this stability in the grid, which is good for the grid also, and which is also commercially good for the customer. One of the main things is demand response algorithm. So the batteries will be built with a demand response algorithm, which will make the batteries to kick in at the right point of time. The demand response algorithm is also going to be sensing the frequency of the grid, the voltage of the grid, the load that is happening inside the campus, or even for that matter in any given location. So the demand response algorithm is very important. This algorithm, apart from this, can also be connected to energy pricing. So what we were discussing is the energy prices can be up and down during the day and during the night. So this also can be integrated into the batteries. And I mean, this is already integrated in the batteries, and they can smartly understand, okay, after 6 o'clock, I should take care of most of the load because the power that is being consumed from the grid is going to be expensive. So the energy pricing integration also are happening in the batteries. Coming to the next one, the state of charge. The batteries are also becoming very smart. They are also being trained with AI management tools. They are coming with AI tools which tells them if you are full, don't wait for the price to go up and then you kick in. If you are full, kick in and then start supporting the load. And if you are full, then there's no point in waiting without discharging the power, which is no use for the battery and also the customer. So the customer need not employ one person there who should always turn on the battery system, turn off. It's not like solar, right? Because the solar kicks in when there is sun and then just goes off when there is no sun. But then the battery has to be smart, which should handle the demand response, which should consider the frequency of the grid, the voltage of the grid to push power, take power. It will also be integrated with the pricing, the energy pricing, and which will also be having an algorithm which is smartly trained by AI to maintain its SOC. So by this way, the batteries are getting smarter and smarter and also um, easily accessible, available, and also getting cheaper, I would say. For what we were buying batteries in future, now the batteries are getting cheaper and easily available. So think of these solutions when you go into the market from now on. Like these solutions are going to be future. We'll also forget about the industrial solutions. Coming to residential also, the same thing can be implemented where you have an electrical car. The car will also discharge power. So you charge the car during your morning hours. Imagine all these things are put up in your car. So the car also knows when to charge, how much to charge, and when to discharge also. When to discharge also. So evening you come park your car from 6 o'clock. 6 o'clock your job is over. You park your car in the house and then connect it to the plug. From 6 o'clock to 9 o'clock, if the energy prices are high, the car will discharge power into your house. And after 9 o'clock, from 9 o'clock to 11 o'clock, when the energy power gets lower, the car will charge itself fully. So this can, it's not can also be integrated. This is already integrated in all these smart cars nowadays. Not in all the cars available. For example, Tesla already has this integrated in it. So this is called vehicle to grid integration. So it will charge and it will also discharge. It's kind of a mini grid formation, you can say, within your house. It will supply you power when the power prices are higher. Yes, yes, sir.
So there is one question from just a minute, sir. Can you share some in the sense safety switch time? Ha. Dupak Sherpa. He has asked how BESS is different from conventional battery, or we are going to cover this in the next slides.
No, I mean, we are almost in the end of the session. So I have
Yeah.
explained almost what I have to explain.
Yes, sir.
And yeah, so it's almost time to take questions. Yes.
So how BESS is different from conventional battery?
So exactly, if you have been listening to the seminar from the beginning, batteries, or even for that matter, solar came into the market just to power remote cabins first. We were installing in India, we were installing solar only on military cabins or cabins which had telephone towers and all those stuff. Then slowly it came into houses when there was power cut. So all these things then started evolving into microgrid and what we were talking about now. So that's basically the difference between the conventional or whatever has been happening now and what we are talking as the future.
Okay, sir. Sir, Mr. George has shared one question. Can you share some insight on the safety aspects of BESS in oil and gas industry?
Mhm.
In oil and gas industry,
So
sir, the presentation is done.
yeah, the presentation is over. There's one last slide
Okay,
which I
just
wanted to
finish.
show this.
Finish it first.
Yeah, I just wanted to show this beautiful picture. This is what we are aiming at, and this is how beautiful the world can be when it is completely. Imagine a main city in India being run by solar, wind, and also hydropower, all renewable sources, having batteries supporting during the non-operational hours of these renewable sources. And there was one comment by Elon Musk. I wanted to say that and finish this topic. He said, if we can harness the power of sun within 100 square mile. So in 100 square mile, the sunlight falling, if you can just harness that power and then put it into a battery of 1 square mile, and if you can balance the system in a nice way, the sun power will supply the city along with the battery for the rest of the life. You just have to balance the system in a nice way. And when the sun is shining, it is going to supply directly from the sun. And when there is unavailability of the sun, it is going to come from the batteries. So that's what I thought of putting a nice picture like this and finishing this session.
Yes, sir.
So over to the questions.
Yes, sir. Yes, sir. This is the number of Shiva sir. It's basically Australia number. Sir, can you just share the email address also, sir? Huh?
Yeah, sure, sir, sure. Yes. I'm not sure if the number is fully visible on the
नहीं, the
screen.
number is visible. It's 614. The start.
Yeah, it
Just a
has
minute.
a
Just a minute.
plus.
Just a
It
minute.
it has a
This
plus. Yeah.
now it's visible. Hmm. Now it's visible. This is international number. Okay.
Yeah, you
Hmm.
can write to me on WhatsApp. I
Hmm.
mean, the number has WhatsApp,
Hmm.
so you can just write to me on WhatsApp,
Hmm.
and I'll also put my Gmail on it.
Hmm. अपार्ट फ्रॉम दिस फ्रेंड्स, मैं आपको ये बताना चाहता हूँ कि भाई शिवा सर हमारे जो ट्रेनिंग सेशंस हैं उसके अंदर दो लेक्चर्स लेने वाले हैं। दैट इज़ एक तो बीईएसएस के ऊपर दो सेशंस रहेंगे और एक डीजीपीवी सिंक के ऊपर रहेगा। तो जो लोग भी शॉर्ट टर्म कोर्सेज करना चाहते हैं या जस्ट सीखना चाहते हैं कि भाई व्हाट इज़ डीजीपीवी सिंक एंड हाउ द थिंग्स आर डन, तो वो उस बैच को ज्वाइन कर सकते हैं। द डिटेल्स आर अवेलेबल ऑन आवर ऑफिशियल वेबसाइट दैट इज़ igrowgreen.info। ये हमारा ट्रेनिंग का पेज है या वेबसाइट है। तो अब हम ज़रा क्वेश्चंस की तरफ बढ़ते हैं। फ्रेंड्स, आप सबके जो क्वेश्चंस हैं आप वो पुटअप कर दिए। शिवा सर, रियाज सर हैज़ shared one question, request you to put some safety aspects of BESS as the news of incident of uh, accidents in battery in EV.
Yeah. Yes. Let me just fix this for now. Um, can you see my screen?
हाँ.
I just introduced my email ID there, nothing else.
यस. हाँ. शिवा सर का
Okay.
ईमेल एड्रेस भी आ गया है। इट्स SIVAKUMARAN शिवा कुमारन SIVA, जस्ट अ मिनट, SIVAKUMARAN 99@gmail.com। ठीक है सर। ओके।
Yeah.
In fact, Shiva sir is going to take detailed lectures in our training sessions. Anyone interested can join that, और उसका details हमारी official website that is igrowgreen.info पे मिल जाएगा। Let's move with the question answer session, sir. Hmm?
Sure.
The
Yes.
first question
So
was from
talking
Riya
about
sir.
the safety. Yes.
Sir, can you just
The
minimize, sir?
safety.
Minimize this.
Okay. You want me to stop sharing
Stop
the
sharing.
thing?
We will take
Okay.
the question answers.
All right.
Okay, the question was for EV safety aspects.
Yeah. So I mean, the battery technologies are also evolving. There have been not only EV, there have also been big fire accidents, incidences in those big power plants where I was talking about 10 megawatt, 20 megawatt. In China, there was a big fire accident in one of the big installations with solar and battery solution. It all happened during the initial stages where the batteries were getting into the market. But I think we have already given enough time for the batteries to evolve. And now, at this point of time, if you are going to purchase a battery, let's say from Huawei, Huawei is making bigger battery solutions. Tesla is making big battery solutions, Powerwall solutions, and also LG Chem has come up with good battery solutions. And Trina has come up with 20 megawatt hour container solutions, big solutions. If you just get into the technical aspects of the container battery solutions, you can see they have integrated so much safety features inside batteries nowadays. So all those silly mistakes which caused big fire accidents have taught the battery manufacturers a big lesson, and they are coming up with better batteries and better storage alternatives.
जी.
In EV, I would say, yeah, I don't have any comment on EV as in because it's yeah, it's a whole different topic, right?
यस.
But eventually,
चलिए.
the batteries have evolved and they are getting safer. Is my comment.
नो इश्यूज है. रिया सर, इनफैक्ट जैसा कि आप सब आपको भी मालूम होगा कि भाई ऐसा नहीं कि इंसिडेंट सिर्फ बैटरीज में ही हुए हैं, और ऐसा हमने सोलर वी हैव सीन मेनी एक्सीडेंट्स इन सोलर पावर प्लांट्स आल्सो द बिकॉज ऑफ हॉटस्पॉट. बहुत सारे इनफैक्ट इन इंडिया भी हमने कई प्रोजेक्ट्स देखे हैं जो जल गए हैं ऑलरेडी, बर्नट आउट है, मतलब कि कम्प्लीटली बर्नट आउट है. तो इट्स ऑल, और ये सब इससे हमने बहुत सारी चीज़ सीखी है दैट नाउ वी नो दैट व्हाट इज़ हॉटस्पॉट एंड व्हाट इज़ द प्रॉब्लम इट कैन डू विद द सिस्टम. Next, can you share some insight on the George sir? Hope this safety aspect point is already cleared with you, because sir has already said that the battery has evolved from for many years, and now everything is taken care, and there are big boys already working in this field. Uh, are there batteries that is इंटरसिंक सेफ? ठीक है, इंटर
Are
INTRES,
they?
इंटर्न INTERNSIC safe. So have you heard of this thing, any term like this, internship safe?
Intrinsic safe. No, sorry.
Vikram Sharma ji, do you have video on vehicle grid integration? हाँ, vehicle to grid. हाँ सर, डू यू हैव एनी वीडियो? नो, हमारे पास तो नहीं है. हाँ, विवेक शर्मा जी, हमारे पास तो नहीं है अभी तक, तो हमने बनाया नहीं है कि व्हीकल टू ग्रिड वाला, लेकिन ये कॉन्सेप्ट है जिसके बारे में बात की जा रही है. वी विल मेक श्योर दैट अगर कुछ ऐसा आता है तो वी विल फॉर श्योर हम वो उसको लेके आएंगे. Augmentation profile while integration 20 years by BESS is in how many years we can get augmentations for BESS? Hemraj Kumar sir.
So now we are talking about technology or technique which we have not many of us have implemented it. I know a few who have tried it at least, but not really implemented it in a way which we were discussing. So the real return on investment factor completely depends on how you will be using it and what is the cost of electricity at your place and what batteries you will be purchasing it. So here I was more talking about it technically. So economically, I have no comments on it until it is being used, started, or at least we started using in India. So soon
बराबर.
we'll have answers to all of this, sir. Yes.
नहीं, ऐसा है हेमराज जी. इनफैक्ट अगर आपने सेकी के टेंडर्स अभी देखे होंगे कुछ हाल ही में, मतलब कि लास्ट फ्यू मंथ्स में भी वी हैव सीन मेनी टेंडर्स कमिंग विथ स्टोरेज सिस्टम आल्सो. एंड हेमराज जी, इसमें एकदम क्लियर है कि भाई ये जो कॉस्ट एंड पेबैक की जो बात होती है, इट डिपेंड्स अपॉन 3-4 फैक्टर्स, जैसा अभी सर ने हमें बताया. कॉस्ट ऑफ इक्विपमेंट, एप्लीकेशन एंड द कॉस्ट ऑफ एनर्जी, और आपकी रिक्वायरमेंट क्या है, इम्पोर्टेंस है. तो इस बेसिस पे उस टेक्नोलॉजी का सिलेक्शन होता है, एंड देन वी कैन मूव अहेड. सोमनाथ जामनाथ जी, ये इस क्वेश्चन का, आपके भी क्वेश्चन का आंसर यही था जो हमने अभी बताया. जॉर्ज साहब का, डू यू नो दैट द बी एस इज ऑल्सो इंटीग्रेटेड विद DG, where DG cannot be discharged as uh, capex has been installed? Do you know that BESS is also integrated in diesel genset, where DG cannot be discharged as capex has been installed? So any
Yeah.
comment?
Yeah. 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 Yeah, yes. He's right. I mean, like, because you cannot start a DG in your campus and start pushing that power into the grid and selling that. as a feed-in tariff from the government. I mean, taking a feed-in tariff for it. So that cannot be done. That as of now in India is not allowed. I mean, like that is not viable also, right? You cannot push power from a DG because DG as of now is a very expensive method of making energy. And the feed-in tariff which we get out of the government is not so viable where you can push power from here and then take it from there. But it can be integrated in BESS. The first part of your question, the answer to it is yes, it can be integrated in BESS when you are performing an off-grid operation. When you are performing an off-grid operation, then the DG can be a very good source to support the battery.
चलिए ठीक है। हुज़ैफ़ा का क्वेश्चन है, फॉर रेसिडेंशियल पर्पस 5 किलोवाट टू 10 किलोवाट विच बैटरी इज़ रिलायबल। विच बैटरी में अभी ऑप्शंस हम पकड़ लेते हैं कि भाई लेड एसिड बैटरीज और एसएमएफ बैटरीज और लेड दिस अभी जो हम लोग बात कर रहे हैं इसकी, विच
Lithium
बैटरी,
ions, right?
लिथियम आयन बैटरी।
Yeah. So, I mean, lithium ion battery is by far, or the lithium ferrous phosphate is by far a very proven, safe battery. Why I'm telling you is because all of us carry that in our pockets every day. All our phones are equipped with a lithium ion battery, and which is a smart battery also because you can see the state of charge. You can see how much the battery is charged. And the next beauty of the battery is you can discharge it up to zero. I'm talking about a lithium ion battery which we all carry in our pockets. So you can discharge it up to zero and again charge it up to 100%. And it's very smart. You can see how much juice is left in the battery. You can see how much power is left in the battery, and you can also see the life of the battery. If you have an iPhone or if you have an Android phone, just go see the life of the battery and it will say the battery is now getting charged only 95% because 5% is gone. When it was new, it was getting charged 100%, but now 5% is gone. There's only 95% of health left in the battery. Considering all this, a lithium ion battery is a very safe battery which can even be operated by a grandmother, I can say. So it's that safe and it is that efficient. And the number of cycles of charging and discharging. Again, take the example of your phone. You charge and discharge your phone once every day. Once every day. The phone that I'm using, I have been using it for 3 years, and I charge and discharge it at least once every day to 0 to 100%. 0 to 100%. So the life of the battery is also good. It's a proven technology than going for all these bulk big batteries which needs maintenance. Maintenance is again a big thing to talk about batteries. So our lithium ions don't need maintenance as well. So
चलिए
I
ठीक।
vote
हुज़ैफ़ा
definitely
जी,
for lithium
तो
ions.
एक्सपेक्ट करते हैं कि भाई आपके क्वेश्चन का आंसर आ गया होगा। और इसमें एक बड़ा अच्छा नाम आज की डेट में मार्केट में आ रहा है, दैट इज़ एम पावर। तो एम पावर आप उसमें देख लीजिएगा, द फैक्ट्री इज़ इन पुणे एंड दे आर वेरी गुड मैन्युफैक्चरर्स, अभी उन्होंने सेटअप किया है। नेक्स्ट राहल, RAHAL, उनका क्वेश्चन है, बैटरी और नेट मीटरिंग, व्हाट टू चूज़। फर्स्ट थिंग, नेट मीटरिंग, फर्स्ट प्रायोरिटी शुड बी नेट मीटरिंग, बिकॉज यहाँ पे आप यूनिट टू यूनिट आपको सेट ऑफ मिलेगा। आपका जो बिजली का बिल है वो 99% कम हो जाएगा, और बाकी अगर बचा तो बैटरी से निकाल लीजिएगा। नेक्स्ट हेमराज जी
No,
के।
it depends. I think it also depends on the environment or see if there is a power cut, for example. You have a net metering possibility where you send one unit and you take back one unit from the grid, which is very good. But imagine a situation where there is a frequent power cut happening in that location. Then, even though the feed-in tariff is very good, you still can opt for BESS.
हाँ,
Just
तो
wanted to add
दैट्स व्हाई
that.
आई एम सेइंग सर, फर्स्ट ऑप्शन इज नेट मीटरिंग एंड देन द
Yeah,
बैटरी।
yeah, correct.
हाँ।
Yes.
हेमराज जी का, एनी सेल अबव 0.25 सेल्सियस, नहीं, सी रेट, हाँ, इट्स नॉट सेल्सियस, इट्स सी रेट, 2
Yeah, charging.
पॉइंट
Yeah.
टू फाइव सी रेट, चार्जिंग रेट, which can get 4 hours backup. Any cell available? Do you know, sir? Any cell available?
Yeah, yeah, they check with Huawei, sir. Check with Huawei and LG Chem.
हम्म,
Yeah,
जॉर्ज सर आपका क्वेश्चन का तो आंसर हो गया था. प्रेम बजाज सर, excellent session, got a thing. Bye bye. Very good, sir, thank you. Hemraj Kumar ji, please share some comments upon SECL tender or GUNL tender, how SECI and GUNL get profited by this. Profit. हेमराज जी, चलिए ठीक है, वी विल ट्राई. ये इनफैक्ट ये हमारे ट्रेनिंग सेशन में आएगा ही आएगा. GUNL को हम कवर करने वाले हैं. इनफैक्ट स्टेट गुजरात और महाराष्ट्र हम उसमें अच्छी तरह कवर करेंगे. Sulabh Shah, how to calculate LCOE for large scale BSS? This is taken care in our kilowatt to megawatt. हाँ दोस्तों, यहाँ पे एक चीज़ और बता दूंगा कि भाई आप में से जो लोग भी इंडस्ट्री में काम कर रहे हैं, हाँ, हम लोगों का एक और सेशन है दैट इज़ कॉल्ड kilowatt to megawatt. Anyone who is interested to migrate or upskill his knowledge from kilowatt to megawatt, then they should opt or they should join this किलोवाट टू मेगावाट सेशन. वहाँ पे अलग अलग बड़े बड़े एक्सपर्ट्स हैं, यानी कि बिग टाइम कंसल्टेंट्स, वो सब एक साथ आएंगे. और मुझे यकीन है कि भाई ये कंसल्टेंट्स को अगर आप खुद अकेले एक एक करके हायर करने जाएंगे तो शायद ही आपको टाइम मिले और शायद ही आपको उतना इन्फॉर्मेशन एक साथ मिल जाए. तो आप सब जो लोग भी जो मेगावाट में अपना करियर बनाना चाहते हैं, दे शुड डेफिनेटली कम एंड जॉइन दिस सेशन, जहाँ पे हम पॉलिसी, प्रोसीजर्स, गाइडलाइंस, लॉज, रूल्स, रेगुलेशन, राइट ऑफ वे, ओपेक्स, कैपेक्स, गोवा, वीएनएम, जीएनएम, ये जितने भी चीज़ें मेगावाट से, इनफैक्ट कुसुम को भी हम कवर कर रहे हैं और एमएसकेवाई को भी कवर कर रहे हैं. तो एमएसकेवाई में कैसे क्या होगा, कुसुम में कैसे क्या होगा, मेगावाट में कैसे क्या होगा, दिस ऑल टॉपिक्स विल बी टेकन केयर बाय ऑल द बिग एक्सपर्ट्स, ऑल द बिग कंसल्टेंट्स. एक्सपर्ट्स तो बोले, दे आर बिग कंसल्टेंट्स, दे आर ऑलरेडी वर्किंग फॉर मैनी गीगावाट्स प्रोजेक्ट्स. तो वो दे आर ऑल कमिंग ऑन दिस प्लेटफॉर्म किलोवाट टू मेगावाट. चलिए, सोमनाथ जामजरी, कैन आई प्लान BESS फॉर एन ऑफ ग्रिड फास्ट DC चार्जर, से 360 kV DC चार्जर इन माई 1 megawatt solar power plant?
yeah, yes, yes, you can. I mean, you can approach SunGrow. We have done a project doing the same, so you can
तो
approach SunGrow
सोमनाथ
for
जाम जी सन ग्रो के पास है, ऐसा किया हुआ है. इनफैक्ट सर ने ही वो प्रोजेक्ट किया है. देखिए, यू कैन अप्रोच सर ऑल्सो, आपके पास डिटेल्स आ चुके हैं. हेमराज जी का, प्लीज शेयर सम सप्लायर्स फॉर EMS एंड 20 feet only open container in India except DCM, Shriram and Jupiter.
which was the question, sir?
Please share some suppliers of EMS and
Uh,
20 feet only open container in India except DCM, Shriram and Jupiter.
no, I have no idea
No
about
idea.
the Indian manufacturers who do big level. But yeah, but if you want to import it, I can definitely recommend because I have trialed and tested and it's been running well. Huawei, Trina, and the LG Chem. I mean, Tesla is always an option, but it's very expensive.
ओके, चलिए. हाँ, अशोक सर, आप तो डायरेक्टली सेशन में आ जाइएगा, आपको ये सारी चीज़ें पता चल जाएगी, इसमें कोई टेंशन वाली बात नहीं है. नीरज गौतम सर का क्वेश्चन ले रहा है, आई वांट टू नो द कॉस्ट ऑफ 15 किलोवाट हाइब्रिड सिस्टम विथ लिथियम आयन बैटरी. नीरज गौतम साहब, इसके लिए तो अभी तो फ्रैंकली आप देखिए 3 जगह पे अप्रोच कर सकते हैं. अगर आप नॉर्थ में हैं तो आप स्टैटकॉन को अप्रोच कर लीजिए, दे आर हैविंग द सोल्यूशन. अगर आप वेस्ट और साउथ में हैं तो आप एनाटेक को अप्रोच कर लीजिए, आपको सोल्यूशन मिल जाएगा. अगर आप बैंगलोर और उसके आजू बाजू हैं तो आप या पूना में हैं तो आप एम पावर को कांटेक्ट कर लीजिए, आपको सोल्यूशन मिल जाएगा. Mr. George, Ajit sir, my question is, it BESS been adopted today in oil and gas industry?
Yeah, yeah. Yes, yes, sir. Yes, it can be adopted. So in a way, if you were, because I know I can remember you were asking about the safety of adopting the battery technique inside this campus. It is very safe, so it can be adopted. Yes.
चलिए ठीक है। अमित जायसवाल सर, आई रिकमेंड दिस कोर्स एज इट्स परफेक्ट लर्निंग फ्रॉम किलोवाट टू मेगावाट ट्रेनिंग। थैंक यू अमित जायसवाल साहब। एंड जितने भी हमारे दोस्त लोग हैं इसमें, तो उनको बस यही बोलूँगा कि भाई वी हैव शॉर्ट टर्म कोर्सेस ऑल्सो। चूँकि आप सब इंडस्ट्री में काम कर रहे होंगे, आपके पास स्टाफ होगा, आप अपने स्टाफ को ये सिखाना चाहते हैं, आप अपने स्टाफ को ये सिखाना चाहते हैं, लेकिन आपने हमारे ट्रेनिंग सेशंस को ज़रूर देखा होगा, लेकिन उसके अंदर बहुत वो आपको लगता होगा कि इट्स ए बिग ट्रेनिंग जिसको अपना करियर बनाना है। ऑब्वियसली वो उन्होंने तो ज्वाइन कर लिया है, वी हैव ऑलरेडी स्टार्टेड। बट आप लोग चाहते हैं कि भाई हम अपने स्टाफ को सिर्फ नेशनल पोर्टल, स्टेट डिस्कॉम का पोर्टल, डीसीआर वाला पोर्टल वो लोग जान लें तो आपका काम हो जाएगा। तो नो डाउट वी हैव शॉर्ट टर्म कोर्सेस ऑल्सो फॉर डिज़ाइनिंग पर्पस एज वेल एज डॉक्यूमेंटेशन पर्पस, बोथ हमारे पास अवेलेबल है। अपार्ट फ्रॉम दिस वी हैव ए सेशन ऑन किलो, इट्स ए बिग सेशन फॉर किलोवाट टू मेगावाट। तो आप सब इसका फ़ायदा ज़रूर उठाइए, नॉलेज को इन्हांस कीजिए, अपने स्टाफ के नॉलेज को इन्हांस कीजिए, आपका ज़रूर फ़ायदा होगा। और फिर से एक और बताता हूँ, शिवा सर इज़ गोइंग टू टेक 3 सेशंस। वन विल बी ऑन डी जी पी वी सिंक, हाउ कंप्लीट उसका टेक्निकल कॉन्फ़िगरेशन के साथ, एंड 2 सेशंस ऑन बी ई एस एस। तो है सोमनाथ जामनाथ सर, एकदम बड़ा अच्छा, वन ऑफ गुड क्वेश्चन। यू ओनली टॉक्ड अबाउट लिथियम सेल्स, आई वॉज एक्सपेक्टिंग दिस क्वेश्चन सर in BESS. What about other cells?
Yeah, yeah, yeah. We were discussing, sir. There are multiple technologies, techniques coming up in terms of storage. So we are only talking about lithium here. We know that there are n number of techniques coming up. We can take it as another session maybe in future.
कोई दिक्कत नहीं सोमनाथ जी, साथ में बने रहिएगा। हाँ, अच्छा, हेमराज सर का क्वेश्चन है, प्लीज शेयर सम पॉइंट ऑन यूएल सर्टिफिकेशन एंड आईईसी सर्टिफिकेशन ऑफ बीईएसएस। इज देयर एनी सर्टिफिकेशन?
Yep, there should be, is what I can say, but I'm not an expert in that field of this industry. So maybe, sir, you can answer well
No,
than me.
I have this BESS is totally new for me also, and I have also not
There
seen.
will be
हाँ,
certifications, sir. There
सर्टिफिकेशन
will
इज
be
हाँ।
certifications for sure. There will be a team which
हेमराज जी,
will
आपने
be
अच्छा
coming
अच्छा अच्छा
to the
टॉपिक हमें दे
certification.
दिया, हमारे लिए भी एक अच्छा होमवर्क मिल जाएगा। वी विल डेफिनेटली डू सम प्रॉपर होमवर्क एंड गेट बैक टू
Yeah.
यू विथ ऑल द नेसेसरी इन्फॉर्मेशन। तो फ्रेंड्स, इसी के साथ हम अपना आज का सेशन ख़त्म करते हैं, एंड वी आर एक्सपेक्टिंग वन मोर सेशन नेक्स्ट वीक, दैट इज़ ऑन लॉज ऑफ ग्रीन हाइड्रोजन। क्या है कि भाई आप सब ग्रीन हाइड्रोजन ये सब आपने सुना होगा, लेकिन देर आर सर्टन लॉज एंड रेगुलेशंस विच नीड्स टू बी फॉलोड बिफोर एंटरिंग इन दिस सेगमेंट। तो जो लोग भी इंटरेस्टेड होंगे, भाई व्हाट आर द लॉज एंड रूल्स इन इंडिया फॉर ग्रीन हाइड्रोजन, तो वो नेक्स्ट वीक का सेशन ज़रूर अटेंड करें। एंड ख़त्म करने से पहले अगेन मैं शिवा सर, वंस अगेन आई एम मी एंड माई व्यूअर्स, उन सब की तरफ से आई से बिग थैंक्स टू यू। एंड
Thank you, sir.
वी
Thank
विल
you, all
हैव
of you.
we will have more sessions in our training sessions. Thanks for the
Yeah.
support, sir.
Yeah. Thank you so much, sir. And yes, like you said, we'll discuss more in detail on the technical aspects in the coming training session. This was just an introduction. So thank you so much. Thanks for all your time and see you in another.